Hey everybody, this is Dr. Ban, and we are going over one of the problems from your homework. This is problem number 1685. And the question is, the pH of a 0.3 molar sodium carbonate solution is adjusted to 12.97 using a strong base. What is the concentration of carbonate in this solution? And the way that we're going to figure this out is by first recognizing that sodium carbonate is a polyprotic acid. So we have 0.3 molar Na2CO3. We have a pH of 12.97, and sodium carbonate can dissociate in the presence of water. So this is a base. This would be our conjugate base of bicarbonate. So CO3 minus plus OH minus. And this would correspond to Kb1, the first Kb. And there are no tables of Kb values, so you have to use the known Ka values in order to calculate your Kb. So the question that we want to get to is, what is the Ka that would correspond to this Kb? Okay, so we need the ultimately we need the concentration of CO3 2 minus. Okay, and we need, so to get that, we need the ultimately what we're going to need is the pKa, because we're going to use the Henderson-Hasselbalch equation, which, if you remember, is pH equals pKa plus, this is plus the log of A minus over HA, to answer this question. If we look at Ka values, so the Kas always starts with the most protonated species. So in this case, we're going to start off with H2CO3 plus water is in equilibrium with H3O plus HCO3 minus. It's K1. And to figure out which Ka corresponds to which Kb, they both have to have the same conjugate base, acid-base pair. Okay, so you can see this has bicarbonate and this has carbonic acid. This has carbonate and bicarbonate, but they're not the same conjugate base pair. So if we take HCO3 minus plus water, dissociates into H3O plus what? CO3 2 minus. Now we see, okay, here's our base, here's our acid, here's our base up here. This could be written as CO3 2 minus plus water. That's fine. Is in equilibrium with HCO3 minus plus OH minus. It's basically the same thing. Okay, so that's Ka2. So Ka2 would correspond to Kb1, and we can get at, and we know what Ka2 is. So Ka2, if you look at our tables, is 4.7 times 10 to the minus 11. So that's Ka2, 4.7 times 10 to the minus 11. Okay, so the pKa, and we could calculate, if we knew the Kb, we could, if we wanted to figure out, for instance, the initial concentration of the initial pH of our solution, we could use the Kb, calculate our OH, and then calculate our pH if we want to do that. That's a different question. So in this case, we're going to calculate the pKa. So we get out our handy-dandy calculator. pKa is equal to minus the log of the Ka. So we have our handy-dandy calculator. So 4.7 times 10 to the minus 11. Okay, and we take the log of that and get a value. So the pKa is 10.3. Bring that back up. 10.33. 10.33. Okay. So we've got our pH, we know our pH, and from that we can calculate our concentration of, we can calculate, or at least we can get an idea of what the ratio of A minus to HA is. So let's figure that out. So we've got the pH is 12.97 equals 10.33 plus the log of A minus over HA. So 12.97 12.97 minus this number is 2.64 equals the log of A minus over HA. So 10 to the 2.64 equals A minus over HA. And that value is, we're just going to take 10 to the x here, is 438.6 equals A minus over HA. So that's basically 438.6 to 1 is our ratio of A minus to HA. But we want to get this into a percent so that we can figure out how much of sodium carbonate is dissociated at that pH. So we're going to say HA, we want to get a percentage out of this. HA plus A minus equals 1, where 1 is going to be 1 is 100%. So we want the concentration of A minus in this case, the percent of A minus. So HA is really A minus divided by 438.6 plus A minus. So that's going to be 438.6. So that's 438.6 A times A minus 436. 436 divided by 438.6 A minus equals 1. So that ends up being 438.6 plus 1 A minus is 439.6 A minus divided by 438 equals 1. And we can cross multiply here. So A minus would be 438.6 divided by 439.6. So A minus equals 438.6 divided by 439.6. So 430 divided by 439.6. It's 0.9978. A minus equals 0.9978. Okay, so that's basically 99.78% is going to be in this carbonate form. So we can multiply that by 0.3 molar and get our concentration of 0.3, which is basically still 0.3, 0.2993. If we look at our answer, it's basically 0.3. So that is the answer to that question. And if you have any more problems or if you have any questions, I know it's getting late, but feel free to email me. Okay, bye.